Okay, so here we are going to show how to use Matlab, right, to show frequency response. We start with a very simple system as example. So in this system, we have only one pole, only one single pole. So in order to show a LTI system, we want to get coefficients A and B for the system. So since this is only one pole, right? No zero. So B is 1 and A we have 1. This is a 0, right? The second is my pole, right? My pole is determined by magnitude and phase, two things. Magnitude now is 0.8. Phase is 3 pi over 4. And my frequency response, sampling frequency is 2000 hertz. 2000 hertz. Okay. Okay, now I change, right, my frequency Z to Fs. Fs. What is this one for? Okay, now let's run it. Right. There are two functions I used in this M file. First one, Z plan. You can plot poles and zeros figure for a system. Second function we call frequency Z, right? Frequency Z. This one can show the frequency response of a system. So we're going to run this section only. So you can click run section in your Matlab. It can only run the first section. Okay, so the first figure I use Z plan. So it shows the poles zeros plot for the system. So this is my pole, right? My pole is at 0.8 3 pi over 4. Okay, this is my 0. And frequency response, I use frequency Z. You can find I have a peak, right, at around 750 hertz, because my sampling frequency is 2000 and the highest frequency I can express is 1000. Now 3 pi over 4 is around 750. Okay, this peak is relative with this pole's position. So we're going to change this pole's position and see what's going on. Okay, so there are two things we can change, right? One is R, another one is theta. So we change R. We make it closer to unit circle. Okay, 0.9. Let's draw it again. Okay, this time we can find now my pole is closer to unit circle, and in terms of frequency response, I have a sharper peak, but the position is still at 750 hertz. Okay, let's make it a little sharper. So we know we're going to make it a little bigger. So it's closer, even closer to unit circle. Okay, I have a sharper one. Right now it's about 40 dB, right? 40 dB gain for this peak. Position still at 750. And if we look at the pole zero figure, right, now it's even closer. Okay. Now we want to change. We want to keep R the same, right? Keep R the same, but we change theta position. Now it's 2 pi over 4, so it's half pi. If we run it, we find still almost the same sharp of this peak, but now it's 500 hertz. So changing theta, we're going to move this peak across frequency. And changing R, we are going to change how sharp or how smooth the peak is. Okay, let's try just one more. Okay, now it's pi over 4. Okay, still same sharp, right, of this peak. Now it goes to 250 hertz. 250 hertz. Okay, so now we summarize. For one single pole system, we're going to have a peak, right? We're going to have a peak in your frequency response. And where it is, this peak, determined by theta. And how sharp or how smooth is this peak, determined by R.